Assalamu alaikum wa rahmatullah wa barakatuh. We return back to second video on this section, or on this section, outside section. We will have to study second kind of permutation, which we call it circular permutation. Permutations that occur when objects are arranged in a circle are called circular permutation. Circular permutation. Two circle permutations are not considered different if corresponding objects in the two arrangements have the same object to their left and to their right. Suppose you have a circular table, and you have a visitor and he wants to sit on a circular table in order to have lunch. You can consider this visitor as the corner, and you can begin to count from his right or from his left. Returning here, this is why we cancel one from total number of persons or things. For example, if 4 persons are playing bridge, we don't get a different permutations if everyone moves to the chair at his or her right. For example, example number 10, how many circular permutations are there of 4 persons playing a bridge? If we arbitrarily consider the position of one of the 4 as fixed, like this, person. Here, this position, we will delete 1 from 4. Then you will have still 3 persons. Then you will have n minus 1 factorial number of ways. But pay attention to a bridge, which will be circular. For the word circular will be n minus 1 factorial. 4 minus 1 factorial, it will be 3 factorial, which is 3 by 2 by 1, 6 ways. 6 ways. Different ways. Other words, there are 6 different circular permutations. We have a theorem, which is theorem 1.5. The number of permutations of n distinct objects arranged in a circle. You must have in the question or in the example, the word circle is n minus 1 factorial, which means n minus 1 multiplied by n minus 2 multiplied by n minus 3, and so on till 2 by 1. Here you will have a book. How many different permutations are there of the letters in the word book? You have 4 letters, n 4 letters, but you have n1 letter B 1, n2 letter O will be 2, n3 letter K 1. We can solve it by another way with the next theorem, but you have here 4 factorial, which is 24. But since you have O, you will have 4 factorial over 2 factorial, which is 12. 12 in 12 ways. I cancel example number 12. Here you will have the last theorem on permutation, generalizing. Suppose you have many different, like a word statistic. Word statistic, you have n equal 10. N1, letter S, 3. N2, letter T, 3. N3, letter A, 1. N4, letter I, 2. N5, letter C, 1. If you notice that here the number of permutations of n objects of which n1 are of one kind, n1 of one kind, n2 are of the second kind, and so on till nk are of kth kind. And also notice n1 plus n2 up to nk equal n. Then you can use this theorem. N factorial over n1 factorial, n2 factorial up to nk factorial. This is why here in example number 113, in how many ways can 2 paintings by Mont, 3 paintings by Ronier, and 2 paintings by Degas be hung side by side on a museum wall if we don't distinguish between the painting by the same artist? Then you have 2 paintings, n1 equal 2, n2 equal 3, n3 equal 2. The total number of paintings n equal 7. Then you will notice that number of ways equal n factorial over n1 factorial, n2 factorial, n3 factorial. Since n equal n1 plus n2 plus n3, which is 7. 7 factorial over 2 factorial multiplied by 3 factorial multiplied by 2 factorial, it will be 210. There are many problems in which we are interested in determining the number of ways in which our object can be selected. This is another subject which is talking about combinations. توافيق combination توافيق permutation تباديل. I will move to solve some problems with you, and after that I will return back to solve or to talk about permutation. Page number 25 in this section has many questions, but I choose for you some questions that we will solve it together, and these are the only questions that you must study it with the solved examples. Question number 37, page 25. In how many ways can 5 persons lie up to get in a bus? Solution.